In this video, we'll use double factorial and factorial to generate the Taylor-Maclaurin series sum of the Fresnel cosine and sine integral and the expansion for both. We begin with the formula of the Fresnel cosine integral, which is the summation of a times x to the power 4n plus 1, while the sine is the summation of a times x to the power n plus 3, and the expansion for both is the summation of a times x to the power 4n plus 1 plus k, where the value of k is 0 or 2. So data validation. List of items 0 or 2. We can start with 0 or 2. And the value of n is from 0 to infinity. So we can start from 0 to infinity. 16 is good enough. For a1, which is the expansion coefficient of the cosine, Fresnel cosine integral, this is our formula, minus 1 raised to the power n. That's the divided by, there are two parts, factorial 2n and the quantity 4n plus 1. So start with the first part, the factorial 2n, 2 times n. Two times n. That's the first part. We'll copy this n value. The second part is the quantity 4n plus 1. So 4 times n plus 1. And enter. So we've completed the expansion coefficient of Fresnel cosine. Now the expansion coefficient of the Fresnel sine, which is our formula, minus 1 raised to the power n. That's the numerator. Now the denominator. The denominator has two parts, factorial 2n plus 1 and the quantity 4n plus 3. So factorial 2n plus 1, 2 times n plus 1 times second part, the quantity 4n plus 3. So the quantity 4 times n plus 3. Then enter. Now the expansion coefficient for both. So this is equal to, we use the double factorial. So our formula, minus 1 raised to the power n. That's the first part. That's the numerator. Now the denominator. The denominator has three parts, double factorial 2n, double factorial 2n minus 1 plus k, and the third part is the quantity 4n plus 1 plus k. So let's start with the first part, double factorial 2 times n. That's the first part. The second part, again, it's double factorial, factorial 2n minus 1, 2 times n minus 1 plus k. This is k. Now finally the third part. The third part is 4n plus 1 plus k. So the quantity times the quantity 4 times n plus 1 plus k. This is our k. Then enter. There is an error if it is k equals 0, but k equals 2. Their values are the same, but there's no error. At k equals 0, their values here are the same. We correct this error with the formula if error. So if error, if error, so one, otherwise calculate. Now it's corrected, so they're the same. They're exactly the same. If k equals 2, they're exactly the same. Now we continue with the expansions. Begin with the Fresnel cosine integral. So R formula, series sum of the x values raised to the power. The power is 4n plus 1. So it starts with 1 and followed by at n equals 0, that's 1. At n equals 1, 4 plus 1 is 5. So 1, 5, 9. So the increment is 4. And the coefficient will be this range. And the expansion for both, which is our formula, series sum of the x values starting, that is raised to the power 4n plus 1 plus k. So we start with 1 plus k. So 1 plus k. That's the starting point. Again, the increment is 4n. So an n is incremented by 1. So 4 times 1, so 4. And the coefficient will be this range. So if this is 0, they're the same. Now we continue with the sign, the Fresnel sign integral. So this is our formula, series sum of the x values raised to the power 4n plus 3. So 4n plus 3 at n equals 0, this is 3. So it starts from 3, incremented by 4, and the coefficient will be this range. Then enter. So if k equals 2, these values are exactly the same. Now we'll chart this. So insert chart. And we use scatter chart. Use row 1 as header. Customize the series. Show the trend line. Polynomial to the 8th degree. And for the label, use the equation. For the legend, position at the bottom. We want to clean this, so we go to the vertical axis. For the vertical axis, the number format will be none. That's better. We don't have yellow, so we go back to the series. This one should be colored green to match our data set. So that's the color for the Fresnel integral of sine. Now for all series, point size is maximum, except for the red one, which is the expansion for both. The point size will be none, but the line thickness will be maximum. So here's our trend line and polynomials of the Fresnel integral cosine and sine. We'll calculate these polynomial regression coefficients using LINEST. To do that, we use the Linus matrix. We start from the power, which is transpose 0 to 8. And the elements of the matrix, so array formula of the x values raised to the power 0 to 8. Then enter. Now we can use Linest. Linest data y for the cosine and data x for the expansion of both. So Linest data y and data x for the Fresnel integral sign, which is again Linest data y and data x. Let's compare the polynomial regression coefficients with our chart. So you can toggle this at k equals 0. These values are exactly the same, and their polynomial regression coefficients, they're the same. K equals 2. The datasets, these datasets are the same, and their polynomial regression coefficients are the same. Let's check. At x equals 0, at x to the 0, 0. Coefficient of x, 0.997 minus 8.38 times 10 to the minus 3. Coefficient of x squared, 0. Coefficient of x cubed, 0.0193.38. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, 0.131, negative 0.131, 0.0591. Coefficient of x to the sixth, 0. Coefficient of x to the seventh, 0.0196 to 0.58 times 10 to the minus 3. Coefficient of x to the 8, 0. We toggle this to 0. Again, coefficient of x to the 0, 0. Coefficient of x, 0.997, 0.99, this is 0.997, and minus 0.838 times 10 to the minus 3. Coefficient of x squared, this is 0. Coefficient of x cubed, 0.0193, 0.38. Coefficient of x to the fourth, 0. Coefficient of x to the fifth, negative 0.131, negative 0.1313, and this is 0.0591. Coefficient of x to the sixth, 0. Coefficient of x to the seventh, 0.0196, 0.0196, this is 0.0196, and 2.58 times 10 to the minus 3. Coefficient of x to the 8, 0. So we can toggle this. If it is sine, these values are the same. If it is cosine, these values are the same. This completes the use of double factorial to generate the trend line and datasets of the Fresnel integrals for cosine and sine.